This is Dr. Shemako. She's working to identify breast cancer patients at risk of bone metastasis to help improve treatment and their quality of life. She leads a team of researchers dedicated to exploring the biology of breast-to-bone cancer at the University of Calgary lab. Dr. Shemako's lab is partnered with the Breast Cancer to Bone Metastasis Research Program. It has identified a previously undiscovered mechanism and is now searching for ways to stop or reduce bone loss. Statistically speaking, 20 to 30% of women who have been treated for breast cancer experience metastasis. Out of that 20 to 30% of women, 70% of them will specifically experience bone metastasis. This is the breakdown of bone due to the cancer cells. Dr. Shemako's research is focused on what happens once breast cancer cells reach the bone and the damage that they can cause. Her research is broken down into 3 phases. Let's go through each phase. Phase 1 started back in 2010, and it consists of 3 steps. Step 1 would be obtaining samples. They looked at the breast cancer tissue from 140 women from the prairies. Some of the women had developed bone metastasis and others had not. Step 2 would be analyzing the samples. Here, they measured the levels of the PROLACTIN protein processor in each sample. Before we keep going, let's understand what the PROLACTIN protein processor does. PROLACTIN is a hormone that aids in breast development. It's present in both males and females. However, females have a higher level of it than males do. The PROLACTIN protein processor is a part of the breast cancer cell that allows it to respond to the hormone prolactin. And now for step 3, they analyzed the results. The results showed that women who developed bone metastasis had a much higher level of the PROLACTIN protein processor than the women who did not develop the bone metastasis. Let's see the next phase. Phase 2 was taken to the lab. Sliced hippopotamus teeth were used for testing as they are most similar to the human bone. They applied bone cells and breast cancer cells grown in the lab to all the samples of hippopotamus teeth. To some of them, they added the PROLACTIN protein. They then waited a week to see if any changes would happen. After a week, they noticed that the group of samples with the PROLACTIN protein has substantial damage. However, the samples without the PROLACTIN did not. Through these analyses, this is what they discovered happens within the body. This is the blood vessel. And this is the cancer cell. The cancer cell flows through the blood vessel into the bone where it meets the bone cell. Now, once the cancer cell reaches the bone cell, the PROLACTIN protein processor acts as an aid in communication between the cancer and the bone. This communication results in pits, which eventually leads to the distortion of the bone. As the cancer cell takes nutrients from the bone, it grows. And as it grows, it continues to communicate with the PROLACTIN protein processor, causing more damage and taking more nutrients from the bone cell, continuing to grow. This becomes a vicious cycle. Let's take a look at the last phase. Phase 3 is the current process. Dr. Shemako is currently working with 500 women. The women were diagnosed with breast cancer 5 years ago. She's testing their blood samples over time to track if the levels of PROLACTIN protein can be used to predict if bone metastasis will develop. Through this process, we can discover if women can be identified as high risk for bone metastasis to the levels of PROLACTIN protein in their blood. The next goal would be to determine if the early treatment with targeted medications improves their outcome and their quality of life. This research and discoveries can be very powerful in changing the lives of many women affected by breast cancer. Dr. Shemako's main goal is to see if her research can be implemented clinically and change people's lives. Such a powerful discovery can positively impact many women all over the world. This is Dr. Shemako. And this is her team.